Welcome everyone. I'm Darlene Tchaikovsky from the Aptucxet Garden Club, and today we are celebrating the 150th anniversary of Arbor Day. And Arbor Day was first observed in the United States in 1872 when J. Sterling Morton, a Nebraska newspaper editor and politician, proposed a tree planting holiday. The idea was to encourage people to plant trees to help combat the deforestation that was happening at that time. So anyway, joining us today are members from the Bourne Library, the Society for the Historic Preservation, the Briggs McDermott House, and the Aptucxet Garden Club. This morning, the first item on our agenda is the presentation by our speaker, Justin Cifello, to discuss and answer questions on the importance of trees in our environment. And Justin is from the Bay End Farm in Bourne. He is an educator, a naturalist, and a farmer. And he received his education at the University at Amherst, Mass, where I come from out that way. And then after Justin's presentation, we will plant a tree at the Briggs McDermott House across the street, and refreshments will be served in the forge. At noon, we will be awarding prizes to the children who participated in our tree contest. I'd like to introduce Justin Cifello.
Yeah, so let's get started. So what is a tree? That's actually a sort of hard question to answer. There's no single term. There's no single definition for what makes a tree a tree. Basically, if a child would draw it and recognize it, we can call it a tree. A tree is what we call a paraphyletic group. That means everything on Earth that we call a tree they're not related to each other. They're from different branches of the tree of life. So that means that, like, we might say a banana tree is a tree, but it has almost no relation to an oak tree, for example. Like a papaya tree is closer in relation to a cabbage plant than it is to a maple tree, for example. So a tree is a form of growth. It's a strategy a plant or a plant-like organism can use. So to get high, to get more access to the sun. So some of the qualities we use when determining if something is a tree, we typically say if something has one trunk, if it's an arbitrary tallness that humans decide is tall enough, generally taller than ourselves, then we're likely to call that a tree. But what happens if we cut down this tree and then it sprouts a bunch of new trunks? It can still be a very large woody organism, but now it has many trunks. We'd still call it a tree? I would think so. And if instead we cut it down to the ground and all that was left was the roots, and those roots sent up a whole forest of suckers, then is that one tree or 1,000 different trees? And a great example of this sort of confusion is the superorganism called pando. It's a giant aspen in Colorado that I think spans more than 100 acres. It's thought to have been on Earth as a continuous organism for the last 15,000 years, going back to the Ice Age. So the reason it couldn't be older than that is because the land there was covered in 2 to 6 miles of solid ice. So that organism, we know about it through pollen samples that people have dug out of lake beds and stream deposits, and they found that they're genetically identical to this giant single tree forest. The individual trunks are only about 150 years old, so walking through it, you would think it's a young forest, but conceptually it's 15,000 years of this continuous organism dying, regrowing, which brings us to another interesting part of how trees are very different than animal life. trees are, plants in general, they're compartmentalizers. So if I were to lob off my pinky finger, it would not be able to regrow. It could not walk off on its own and start a new human. Trees, they can do that. If a branch falls, it can land and it can start a new organism. And if a tree has an infection, it can wall that off and lose that limb and compartmentalize any issues. The inverse of that is trees actually cannot heal themselves like we can. If I get a cut, my skin will regrow and it'll create identical new skin that's functional. Trees don't really do that. They will regrow, but they can't heal in the same way that we do. So we work pretty differently. So yeah, this pando tree is about the oldest, thought to be about the oldest living thing on Earth. But again, it's hard to say, is it an individual? Is it a colony? So about the next oldest tree on Earth are some Norway spruces up in Scandinavia. And those trees are sort of using the stump method of being a very old tree. So there's some stumps in Norway that they've dated to about 9,000 years old. And just with glaciation, with storms, the tops of the trees keep growing and then dying, and then growing and then dying. But meanwhile, the same stump has kept going for 9,000 years. So that's a pretty long time. We'll put 15,000 here. But when you Google the oldest trees on Earth, what you'll typically get answers for are the oldest single trunked trees, where a single tree has been there for thousands of years, and they can bore into the wood and count those rings, and they can tell exactly how old that tree is. So the oldest trees on Earth, by that definition, the oldest standing trunks, are 4,000 to 5,000 years old. And those are the bristlecone pines in California. But all of this needs to be understood with a grain of salt, in that these are maybe some of the oldest organisms, but they're also the closest studied. We haven't analyzed every single tree on Earth. There's certainly older, bigger, larger organisms out there that just haven't been found yet. I think it's probably a coincidence that the oldest trees on Earth are all pretty close to major learning centers where there are a lot of scientists, like in California and Scandinavia. So they have been finding, now that they're expanding their search, they've been finding similarly old trees in Central America, South America, and even in like the deserts of the Middle East, there are still almost 5,000-year-old trees there. So it can be a little hard to study. And the oldest trees, like let's pretend these are redwoods, absolutely giant. A person would be like that big down there. They can be as big as this room around. If you've never been there, you absolutely should try to go. It's really easy to think that the oldest trees on Earth must be the largest. But the redwoods, I mean, they're still really old. They're like 2,000 years old. The oldest trees on Earth are like these little scraggly pines on the top of mountaintops, the bristlecone pines. Those are pushing 5,000 years. I think the oldest ones are about 4,900. And walking by them, you'd say, yeah, that's an old gnarly tree, but it's hard to imagine that it's been around that long. They mostly look half dead. And it was actually a major surprise to scientists. They were studying ring cores, so they have special drills that can cut into a tree and slice out a section of the rings, and then they can count them and analyze the climactic history, because every year when trees grow, they record the weather of that year, how much water, how much sunlight they had, how much growth they were able to put on, if there was a fire, if there was insect damage. That'll be recorded microscopically in every tree ring. So compiling all the different tree rings around the world, we have a pretty good record of past climactic events and when certain trees were started and whatnot. So they were doing some Ice Age science on some bristlecone pines in California. And the scientist, I think this was back in the 80s, the scientist got his core stuck. And so he went and got the next core, and that one got stuck. And these drills are thousands of dollars. They're so expensive. And there are hundreds of these trees. So he called the Park Service and said, I got my drill stuck. Do I have permission to cut down this tree? And they're like, oh yeah, there's thousands of them out there. Just, use it for science, get all the data you can. And so he was counting the rings afterwards and got 2,000 rings, 3,000 rings, 4,000 rings, 5,000 rings. And he realized he had discovered the oldest organism on Earth, and he killed it. It was a tragedy. He had to leave the profession of forestry. He went into geologic sciences. He didn't have to change his name, though, which surprised me. Thankfully, they've since found trees in that stand that are older than the one that he had cut down by accident. And again, he had permission. He was not a bad guy. I feel so bad for him. He must have really regretted that. But his discovery did lead to that being discovered, that there were that old of trees over there. So those are now all preserved, thankfully. So the concept of how old a tree is kind of complicated because they're so functionally different, as is what a tree even is. So let's go back to that concept, that a tree is something tall, whatever we want to say is tall enough to be a tree. Pretty much you decide in your backyard, is it this high, is it a tree? Is it this high, is it a tree? Trees have wood. That tends to be a pretty important distinction for what we would say is a tree. But that gets a little weirder when you go south into the tropics, because palm trees, banana trees, coconut trees, they all have tree in the name. If you asked a child to draw a tree, they might draw a palm tree. If you saw a picture of one, you'd recognize it as a tree. But they don't make wood. They don't make growth rings. They don't make lignin, which is a strong compound that holds wood together. So they decay somewhat rapidly. And they don't grow the same way as our woody trees. They don't make branches off of themselves. In a way, they're a giant grass. A banana tree is closer related to grass than it is to an oak tree. They can't make branches, and when a banana tree makes flowers, like a grass, that stalk will die after the clutch of bananas happens, and it grows another stalk. So a banana tree will make a stalk, a stalk, a stalk, a stalk, and then gradually those will die, fall to the ground, and a new one will happen. So they're a giant herbaceous perennial. So they can still get 30, 40 feet tall, even taller, and there are palm trees that are, I think, almost 100 feet tall. So they're still, I think they're still trees, but they're not technically trees in the way that some people define them. The other middle ground are shrubs. There are plenty of shrubs that, have a very shrubby growth pattern with a lot of branches. Would call that a shrub. But as it ages, these ones, the lower ones, might die off, and it'll get a single leader that can still get 20, 30 feet tall, like a bayberry bush. We see them a lot around the beach here. They tend to only be about yay high, and we see them as a shrub. But if you look closely, often in the middle, there will be one that's got a trunk like this and can be a full-on tree. So tree is a pretty squishy term. If you want it to be a tree, it can be a tree. So we have any questions about any of that before I move on? Cool. So the topic of age, let's start at the beginning. So life on Earth got started pretty quickly after the Earth cooled down, somewhere between 3 and 4 billion years ago, long time. Most of that time it was in the oceans. It's not until like 450 million years ago that life started to happen on land. And when it did, it was mostly just like a crust of algae. Couldn't really get up off the ground. And of course, there wasn't any soil, because soil is made out of decomposed things. So at first, it was just rock with algae on it, maybe some fungus. And the algae could make energy from the sunlight via photosynthesis. And the fungus could use its fine threading root-like structures called mycelium to get into the rock and pull nutrients out. But neither of them could really achieve any height. And it's thought that they started to fuse together into lichen-like organisms. Lichen is actually a combination. It's a symbiote of algae, fungus, yeast. Some even have bacteria. So they suspect that the fungus provided a structure, and the algae was able to fill that structure with a photosynthetic material and create these taller branching organisms. So when you look at the lichen crust on trees and rocks and metal, that's not exactly what the oldest life on Earth is, but something like it, the oldest life on land at least. So the oldest things we might call a tree happened pretty shortly after, around 450 million years ago. There's fossils called Prototaxites. Nobody knows what they were. We don't know what they were. They might have been giant mushrooms, they might have been early plants, but they were like 30 feet tall. Really simple. The fossils are just like a big rounded pillar. And they think maybe the whole thing was covered in algae. Whatever they were, they don't exist. They don't appear to have evolved into any living form of life. So there's a lot of mysteries still in the fossil record. After those, we get the mosses, the club mosses. That's when plants evolved structure. They started to be able to move water up into themselves. They started to develop things that we might call leaves, but they didn't have seeds. So the early forests of the Earth were actually mosses. And these were giant mosses. Some were 100 feet tall. So next time you go in the woods and you see the little club mosses, people will call them princess pines. They're not a pine, they're a moss. Not even a moss, they're a club moss. A lot of categories here. But imagine them being 100 feet tall and being forests made out of them. So when those grew, they were a new development, these giant woody-ish forests, and they died, they started falling over. But bacteria hadn't yet evolved to break them down. So all that matter just piled up on top of itself in these thick mats of not really decaying wood. And we call that era the Carboniferous era, because those bacteria hadn't learned how to break down that woody carbon into soils. So it compressed and turned into a lot of the fossil fuels we have today. Now the bacteria is smarter and it can break stuff down. So when a limb falls in the forest, it's only going to last a few years depending on the conditions. But back then, they would last thousands, maybe millions of years. So then we had the club moss forest, then we get the fern forest and the seed ferns. So this is getting into the beginning of the dinosaur era, the Jurassic and the Cretaceous. And so let's say this whole board was the timeline of the Earth, and we have 4 billion years ago. So we'd have 2 billion here, 1 billion here, trees, and basically everything we know is in this little corner here. So to give you a sense of that scale, let's just look at the last 4 million years, or 400 million years rather, for when we had plants on Earth. So the halfway mark here, and then the modern day. The dinosaurs died around here. When we think of the dinosaurs, we think that's a long time ago. But this is only a fraction of our 4 billion year history, and pretty much all modern plants are just from this section. The oldest plants on Earth that have had a continuous existence are ginkgo trees. They're planted a lot now. They evolved somewhere around here. Super primitive, super ancient tree, and they were actually almost wiped out entirely from the entire Earth, except for a few pockets of valleys, protected valleys in China. And they ended up being preserved by Buddhist monks. And now, they're being planted all around the world again. So you can find fossil ginkgo leaves that are identical to ginkgo leaves today. A few years ago, I went to a petrified forest in eastern Washington state, and I was surprised to see they were all ginkgo trees. We had ginkgo trees here too, but all the ice ages and everything pushed them back to isolated places we called refugia, those valleys in China. And in a testament to the ginkgo's survivability, let me draw a leaf in case you're not familiar with them. They're really distinct. They're got this rounded edge, usually with a split or two in it. They planted ginkgo trees a lot around Buddhist temples. And during the atomic bombs in Japan, some of the only surviving trees were ginkgo trees that were actually fairly close to the detonation sites. So they were almost wiped out of the earth except for a few special valleys, and now they're almost everywhere and they can even handle atomic bombs, almost. So where were we? We're about the beginning of the dinosaur era. We start to see ginkgo trees, we start to see things that look like modern pines, the evergreen trees, and then we get flowering plants. So of all the trees on Earth today, they're in two groups now, the gymnosperms and the angiosperms. Gymnosperms, it means naked seed. Those are trees that don't flower and their fruit is just a seed, doesn't have a whole lot of food to it. That's mostly what we call the conifers. So the gymnosperms are things like pine trees, yews, hemlocks, and there's a few exceptions because there's always exception. The leafy ginkgo is actually one of the gymnosperms, even though it has leaves. It just diverged from them so early on, it was able to invent something kind of different. So the pine trees, they don't make flowers in a botanical sense. They still make seeds, they still make pollen. It's close enough, we can call them a flower. If we're allergic to them, we can call them a flower. So they diverged around 150 million years ago, I believe, from the broad-leafed flowering plants. So if you see basically anything except for a ginkgo tree, if it has leaves that you would call a leaf, it's an angiosperm, a flowering plant. So even if you've never seen it flower, pretty much any plant you walk by in the woods is going to flower unless it's a fern, unless it's a moss, unless it's a seaweed. It'll have a flower at some point in its life. And the evolution of flowers just jump-started plant diversification because flowers, being a sexual organ, allowed genetics to be much more inventive and to happen much faster. So especially once they got animals involved. All the first pollen and spore exchange, that relied on the wind. So the wind blows, who knows where that pollen is going to go. Those plants had to devote huge amounts of resources to making boatloads of pollen to just throw to the wind and hope it landed in the right spot. Angiosperms were a little smarter. The flowering plants could team up with insects. And the first insects to pollinate were actually beetles because they were coming to eat the decaying plant parts, and then they would go eat another decaying plant part. So some of the oldest surviving flowering trees are still pollinated by beetles. So these are things like magnolia. Magnolias are some of the oldest flowering plants we have. They're often a symbol of these ancient flowering plants. And their flowers are a little bit simpler, too, in their structure. So eventually, over time, we had entire groups of insects devoted entirely to pollination. And then we get the really specialized pollinators. And now, flowering plants, they can devote a lot of resources to other things. They don't need to make nearly as much pollen because they can have a bee come and bring it right to where it needs to go. So now they can afford to put a lot more resources into making big fruit, growing faster, growing these wide, expensive leaves that they throw away every fall. Pine trees are much more conservative. Their leaves, look at how skinny these things are. They're still leaves, even though we call them needles. But they keep them year after year because they need to devote so much energy to filling their cones with a bunch of seeds that are going to get blown who knows where, and to make all that pollen because they don't know where it's going to go. So the flowering plants, they're able to diversify. Most species of plant on Earth now are flowering plants. There's hundreds of thousands of species. And I think there's only like 900 species of the gymnosperms, the pine trees and friends. So these tend to be, they'll grow all over the world. We think of them as a northern thing, but they grow in the tropics, often up in mountains. They grow pretty much in places where conditions are hard enough that the broadleaves plants can't quite cut it. Because again, these are much more conservative with their nutrient use. These skinny leaves that they have really hold on to moisture very well. Their growth structure is like a spear growing straight up. All their weight is stacked onto that same supporting trunk, so they can handle snow, they can handle wind much better than our branching flowering trees. Let me write these words down in case you wanted to take any notes. Gymnosperms, angiosperms. And this is broadly things with cones and things with flowers. There's always exceptions, but that's more or less how it goes. Some of these are weird. Some of the exceptions are like juniper trees and yew trees. We'll see them. They have what we would call a berry, but they're technically modified cones. It's really hard to categorize plants with any words in the English language because there's always some exception somewhere. So I think that pretty much takes us up to the modern day for our plant history. So let's think a little bit more about where we are in New England. This land was covered in miles of ice about 15,000 years ago, the glaciers. And as they pushed down from the north, they picked up all these rocks, they scraped the landscape clean, so we had a bare slate in terms of vegetation. Then they dropped all of those deposits in a big mound that we now call Cape Cod. So back then, so much water was locked up in the glaciers that the ocean was actually like 100 miles away. There were wide grassy plains, there were woolly mammoth and rhinos and stuff. As the glaciers melted, there was a huge flood of fresh water that carved the landscape into the shape it is now and further wiped away any remaining vegetation. So it's unlikely that many seeds were left under the glaciers that would have survived under the glaciers. So life had to migrate back north from the south. So the first species to come up from the south would have all been wind-dispersed species that rely on the wind to spread their seeds. So that's a lot of the pine trees. So for millions or thousands of years after the glaciers, the land was mostly pine trees, with the exceptions of like a few wind-dispersed flowering trees like birches and poplars and alders. And then gradually animals were able to carry acorns and berries and heavier seed-bearing fruits up. So the story of our landscape is one of reconquest. There are no trees here that are much older than 400 years old because pretty much all of them were cut down by the colonists. It's really hard to get truth out of the colonial record because they were famous exaggerators. A lot of them were writing to impress the people back home about how either great or how awful and scary this place was. So we have totally opposite accounts of the landscape from that time period. It's also likely they were seeing it different aspects that had different landscape regimes that were done by the indigenous communities. Because the Wampanoag and other tribes would burn the forests every year. Sounds counterintuitive to us, but that actually can increase the life-giving capacity of the forest by thinning out some of the older stuff and creating a lot of new growth. Left to its own devices, the forest will eventually turn into a mature forest that doesn't have a lot of shrubs, doesn't have a lot of berry-bearing fruits. So those burnings were pretty integral. So that created a forest that was occasionally described as park-like, with massive trees, with wide grassy areas in between full of berry-bearing fruits. Some of the colonists wrote that they could ride a carriage through the forest. It was so open. But of course, others said it was a thick and dark, impenetrable mess. So you got to take all those accounts with a grain of salt. But over the few hundred years after colonization, the colonists had to heat all their houses, so they had to cut down most of the trees either for firewood or for agriculture. It's thought that about 95% of our forests were cut. So the oldest trees now in Massachusetts tend to be either little scraggly things on the side of mountains that no one bothered getting to, or specimen trees that were planted by early colonists and captains. So like surprisingly, all the oldest trees known on Cape Cod were all like planted by captains. So they're all European and Asian species. They're not actually native ones because they were cutting the native ones for firewood. And that's also why you'll see all across the Cape, you'll see like firewood landing. I think there's one in Aptucxet, because we had to have our firewood shipped from Maine. There were so few trees here. Thoreau, on his walk across Cape Cod, again, a famous exaggerator, but he wrote that the birds were so grateful for the telegraph wires because they now had a place to perch, because there were so few trees on the Cape. And the lack of trees destabilized the land. So he called it the deserts of Nauset, the plains of Nauset. There were huge shifting sand dunes that would roll through and like bury sections of town, like the railroad wasn't always able to run. Gradually the forest was reestablished, and one of the main species here that we have that took part in that is the pitch pine. And pitch pines are really interesting. We might overlook them here because they're so very common, but they're actually a globally kind of rare tree, and we're in a very globally interesting environment called the Pine Barrens. Barren, sort of an unfortunate word because it's totally unique and there's definitely a lot of life there. It's called barren because these grow on sandy places with acidic soils where few other things can grow. And since it's so dry and sandy, there also tends to be a lot of fire in these environments. So pitch pines are a tree that loves change. That's partly why they look scrubby, because they need to handle a lot. You only see them growing on beaches, on mountaintops, and in places that have experienced pretty significant disturbance. They have some superpowers where they're the only pine in our area that can grow needles out of its trunk. So a forest fire might sweep through, and the white pine, which is everywhere as well, it has, see this thin, smooth bark? It can't handle fire whatsoever. An adult tree can, but the young ones cannot. Pitch pines, however, have this armored bark. So a fire might come through, take out all their branches, and on a white pine, all of their new buds are in their branch tips, it'll never grow another needle out of here, ever. It's impossible. A pitch pine, however, you can even cut down a pitch pine log and leave it aside, and its trunk might sprout needles out of it. They also have specialized cones. I couldn't find any, but some of their cones will only open in the presence of fire. Depends. Trees have some sort of memory. We don't entirely understand how that works. I really try not to anthropomorphize too much, but trees keep records. They have those rings. They have these complicated hormone systems. They apparently know something about their own history. So here, we've suppressed fires. We don't have as many fires. So pitch pines on Cape Cod don't produce many of the fire cones. Most of their cones open like a regular pine cone. But in the much larger pine barrens of New Jersey, their pitch pine trees will maybe make half of them will be fire cones because they have more of a history of fire. They know they're going to need it. Plants can't predict the future. Often people will think, oh, look at all these acorns. This must be a hard winter coming up. Plants work 3 years behind schedule. So if we get a lot of rain this year's buds on the tree will be next year's leaves and next year's flowers and next year's acorns. Some acorns might take 2 or 3 years to mature. So if you see a lot of acorns, a lot of pine cones 1 year, that says more about 2 or 3 years ago than it does about the future. So on Cape Cod, we had cut down most of our trees. A lot of these ones regrew. One thing that's really special here, we're about at the northern extent of their range, are the Atlantic white cedar. They grow in cedar swamps, which are just truly incredible dark places. They're almost cathedral-like. Their wood is so rot resistant because they're in swamps that they're really prized for shingles, for fences. People use them for pipes because they're naturally antimicrobial. And they're so rot resistant that when they die and fall into a swamp, they could be mined out of that swamp and turned into shingles. So we've lost about 70% of our wetlands in Massachusetts, and a lot of them were cedar swamps. So people would cut down the cedars, then they would mine the cedars out of the fallen peat. They would mine the peat to burn and to use for agriculture. And that peat was really acidic, so it could pull iron out of the soil and concentrate it into iron ingots. That's why we see a lot of furnaces around here. Furnace Brook Parkway, for example. Not that close, but it's the same idea. There's a lot in Wareham. There's a big iron industry there. So the boggy areas, first they would extract the trees, they would extract the peat, they would extract the iron. Now they had this big sandy wet area. What can we do with that? Cranberries. So that's how we get cranberry bogs. So if you hike pretty much anywhere in the area, if it's a low sandy area, you'll find some evidence of cranberry bogs, ditches in the ground, even though right now it might be covered in 70-foot tall white pine trees. It was once a totally different sort of forest. So I think without the slideshow, that pretty much brings us to the modern day for the history of plants. Just do a quick overview of our different kinds of leaves. When you're out looking at some trees, these are the main categories. We can have a simple leaf, plain leaf, not much to describe. We call the edge a margin. So it's a simple leaf, it's entire. The next sort of complication are single leaves, but now they're lobed. Now they have teeth. These are like our maples, our sweet gums, horse chestnuts, things like that. Oak trees, also a simple leaf that has a lobe. The complicated ones are things like hickory or all the locust trees outside, where you have multiple leaflets on a single stem. So that can be a little tricky to identify because you might look at this and think it's one of these. But while this is one whole leaf, so is this. So something, if you're trying to ID trees, this is a major category to look for. The other major category is how exactly they branch. So trees can either branch once at every node where the branch comes out, we call that a node. That kind we call opposite. Not too many trees have opposite branches. So if you find an opposite branched tree, you'll probably be able to identify it. That would be things like this maple tree here. See that clear Y? That's an example of opposite branching. Ash trees, dogwood trees, they do that too. Most trees do alternating branches, where they come out like that. So that would be alternate. A very important category to look for when you're trying to ID trees. This is the first thing I always go to. One thing to keep in mind, trees can get damaged. So if you have a maple tree that's had some damage, it might start to look like an alternate tree, but eventually you can find those opposite branches. So we got the branches, we got the leaves and roots. There is a thought. Some people, a lot of people have these tattoos perhaps, where you'll have a nice big spreading crown on a tree, and then you'll have the ground, and you'll have a nice mirror image of the tree. That is not how trees work, sadly. Makes a lovely poster, but trees rarely go into the ground more than 2 feet. So when it starts to grow, you'll have a little taproot, but then they quickly spread out to the side. Most trees are within, pretty much all the trees are within the top 6 feet of the ground. They don't tend to go that deep. There's always exceptions. There's some desert trees in Africa that go almost 300 feet down. So they're almost as tall as some of the tallest trees are tall. So that's an important misconception that a lot of folks have. I think that's pretty much the tree parts. Do we have any questions about anything we've discussed? Yes?
I went and saw that General Sherman tree.
Yeah.
Can you talk about that at all? I thought that was the oldest tree.
So that's one of the largest trees, but it's not one of the oldest. It might be one of the oldest redwoods, but to my understanding, the oldest documented tree is Methuselah. It's a bristlecone pine in the Sierra Nevadas. But again, when I did that intro with all the different kinds, it's kind of hard to say, like if you go online and look up what's the oldest tree, you'll find dozens of articles claiming different trees because there's so many micro categories. But I think General Sherman is one of the oldest of that species. I don't think it's the oldest tree on Earth. Let's see, we have a few here. I wanted to point out the sassafras tree. Well, we don't need to go through all of these, but you can come up and look at them afterwards. But the one I wanted to point out was sassafras because it has such an interesting history here. Sassafras is sort of obscure now, but it was once one of the most economically important trees of the East Coast. It was included in the charters of various states. Various colonies had to commit to sending so much sassafras back to England because they used it as a panacea for all sorts of ailments. Unfortunately, it's been determined the roots are actually carcinogenic. So the root extracts were not a great idea. The leaves are fine. The leaves don't have that compound in them to the extreme quantity, and those are used to make gumbo. Gumbo filets made out of sassafras leaves. It was at one of the first plants exported, and they would export hundreds of tons on a ship to the point that now the only sassafras trees around are about yay big, but they can get, there's one in Sandwich I found that was about this big, and there's one in Kentucky that I think is like 30 feet around. So they can get pretty big. Yep.
What did they use the sassafras for when they shipped it to England?
So that was to make tinctures. They would use it for medicine. And those early medicines, they tasted pretty bad, and sassafras tastes good. So they also used it as a flavor. And a lot of those early medicines transformed into sodas. That's why we call tonics. And root beer. Sassafras was an ingredient in root beer, as well as birch and whatnot. So yeah, if anybody has any questions about other trees I have up here, or trees in the area, or anybody wants to come and look at any of these? Yeah?
Can you explain again about a pine barren? Because I think there's a big one out on the base they've been talking.
Yeah.
And I'm not, like you say, the word barren is confusing.
Yeah. So pine barrens, I describe them as like wannabe deserts. They're a unique feature of the coastal sand plain. So when the glaciers were melting, have you ever seen on a puddle how sometimes the earth will be naturally sorted to, like, there's sand in one part of the dry puddle, and then darker earth, the silt, and then the very darkest clay is at the bottom? When the glaciers were melting, a similar thing happened. So all the sand landed in one place, all the silt went a little further, and all the clay went further than that. So we ended up with a lot of the heavy particles, the sand and the gravel here, and those particles don't hold on to water. So even though we get a bit of rain here, I mean, we're about one of the driest parts of New England, but we're not a desert environment by any stretch. The ground can't hold on to that water. So it ends up being a sort of fake desert. There's plenty of rain, but not a lot of water is actually in the soil. It all drains out into the kettle ponds. So if you have any sort of elevation, those plants don't have significant access to water, and they're very likely to burn. So the pine barrens are the plant communities that have adapted for the drought and the fire resistance. So they tend to have waxy leaves. A lot of them are aromatic and they smell really nice, like wintergreen. And of course, the pitch pines are pretty fragrant as well. And a lot of them actually have flammable leaves and needles because they want the area to burn, so they have guaranteed real estate as the only ones who can survive the fire. But yeah, it's a globally rare ecosystem. The largest ones are in New Jersey, and the next largest ones are here, Miles Standish State Park, and all across the Cape. If you find a forest that's mostly pitch pines and oaks, that'll be a pine barrens. They have a lot of unique animals that live in them too. A lot of special butterflies only live in the pine barrens, including, I think, North America's largest butterfly, the Cecropia moth. I think those are endemic to pine barrens. Any other questions?
We should, I think one of the most trees that should get the most notoriety in our area is Main Street, Buzzards Bay, Red Top Sporting.
Yeah, I've long thought that if we didn't have the train bridge, that would be the icon of Buzzards Bay. There's a rock with I think it's an oak or a cherry growing out of it. It's pretty stunning. If you haven't seen it, you should see it.
Some years ago, I thought that tree's got a couple years left.
And it's still going.
Great.
Yeah, and that's a great example of how trees, I've heard it said, trees are alive until they're dead. Trees don't age the way that humans do. Eventually, we could be the most healthy person with the best diet. Eventually, our parts just age and they don't work as well. A tree, as long as it's in a good environment, can theoretically exist indefinitely, forever. We don't have a vacuum like that to test this, but it's thought that trees don't senesce. They don't deteriorate with age. As long as there's a little bit of living tissue, that tree can theoretically regrow itself entirely as a fresh new organism.
Okay, we're going to wrap this up and just want to thank Justin, and we're going to do phase 2 over at Briggs McDermott. So
thank you. Time to plant a tree. Here we have a fringe tree. It's a gorgeous flowering tree. This actually brings up something I forgot to mention in the talk about some big categories we use for trees. Namely like native and non-native. fringe tree is kind of in the middle. It's a native to the East Coast tree, so it's something we call a near native. We're just far enough north that we're just north of a lot of the trees that are naturally in our range. Like, we're surrounded by these craggy barked locusts. Those are another near native, so they're part of that northward movement. With climate change and everything, it's actually really important that we start planting these near natives a little bit further north, because we can plant them a lot faster than the trees are capable of moving by themselves. So something to consider when you're shopping for plants is, if you're a real native plant purist, you should go online to GoBotany or bonap.com.org, and those will have you like county specific maps of what is native to the region. But I think having a flowering tree of any kind is a improvement on not having a tree, so I'm not a purist whatsoever on that front. But that's to say, being non-native does not mean it's invasive. An invasive tree is one that comes in, it's from elsewhere, there's nothing here naturally that can keep it in check, so they will grow rampant and shade out other life and ultimately reduce tree diversity. Luckily, most non-native plants are not invasive. Most non-native plants are not a problem. So you do not need to worry about your, like the lovely lilac over there. That's not going to be taking over the forest in the same way that this invasive honeysuckle and multiflora rose will. Right now, if a tree has leaves on it, there's a good chance it's a non-native or it's a near native, because our local trees, they're still holding on because we might get another snowstorm. Who knows? They're used to some unpredictable weather.
We did have it in 1976.
So here we have a nice little hole for our
Very heavy snowstorm that broke my young apple tree in May. Mother's Day weekend.
Hopefully we can get this out of this pot. There we go. So when planting a tree, it's always good to
Massage it.
rough up those roots. It's a little bit of a disturbance to the tree, but it's pretty important so that they don't just continuously circle themselves. And it can stimulate new growth up at the top of the tree.
I think you should use the knife. Or the shovel.
And the same with plants, though, any kind of plant,
Yep.
a shrub?
No, I'll just use my hands because I don't want to cut it up too much.
Okay.
I want to let them kind of detangle, like you're using a detangler in your hair. So tree roots, as cool as they are not terribly sophisticated at foraging for nutrients. Pretty much every tree on Earth relies on partnering with fungus to help gather nutrients out of the soil. Sort of like that early ancient partnership, thank you, between the fungus and algae that created the first plants on Earth. So most fungi, we tend to think of them as maybe being bad things, like rotting trees out. Most are actually beneficial, and they will create sheaths over the roots. And those sheaths will reach out into the soil and forage for nutrients and exchange water. And they even allow trees to share nutrients with each other. So like a pine tree in the winter is making a little more sugar than it needs, so it'll send some sugar over to a nearby birch tree, for example, who doesn't have any leaves. And then in the height of summer, that flow will reverse. So the whole concept of nature being red in tooth and claw, full of competition, totally true, but it's not the only picture. There's a lot of cooperation. All the trees have a vested interest in the forest surviving. A birch tree doesn't necessarily want a forest of only birch trees. It wants a diverse forest because that's much healthier. If a disease comes through, it's really helpful to have many other varieties that aren't affected by that same disease. Which is another reason that's good to plant an unusual species like this, because if we planted, say, a red maple, which is the most common tree on the East Coast, it's actually the most common tree in North America. Lovely tree, I have nothing against it, but if a disease were to come that hits maples, we'd lose all of them. Like we did with the elm tree on the other side of the building. Every street, every town in like New England has an elm street because they were everywhere. Sadly, there was a blight. Same with the chestnuts. So tree diversity is great. Sense of how deep it is. Put some soil into the bottom. Wiping away some of the mulch from the base of the tree. All right, give me some artistic guidance. Where?
Yeah.
Yeah?
Yeah.
Should I rotate it at all? Do we like where it is?
Looks good. Maybe somebody should hold it.
How's it now?
No,
Perfect.
Yeah.
Perfect.
Yeah, okay.
Yeah. Yeah. People on both sides also, how's it look from your angles on the edge? Great.
It's going to be really pretty. It's going to be beautiful. It
Don't
is.
want, it's good to pack down the soil a little bit so that when it gets its first water, that soil doesn't all compact with the water and then it would shift around. Put some of the original soil back on top. You can see how sandy our local soils are, which a lot of people complain about, but it's something of a blessing because sandy soils are very well drained. If your soil around a new planting is too heavy, it'll never get to dry out. And the tree wants to dry out a little bit because trees actually absorb a lot of oxygen through their roots. It's hard to imagine there being oxygen under the ground, but there is. If any of you have seen pictures of those cypress trees in the Carolinas and Louisiana, they grow in anoxic environments, so they grow special roots that actually come out of the ground to do their breathing for them. We call them knees. Having some well-draining soil mixed in is important. Otherwise, if it's always wet, the tree will never bother growing roots out further.
That's lazy.
Yeah. We had that issue on the farm with, we tried a new irrigation technique, a drip irrigation, where there's a targeted drip of water right at the base of the plant. We found when we put them too close, the plants never really reach further than that, and they're not anchored into the ground. The wind comes, they just blow over. So you have to make them work for the water a little bit. Not packing it down too much, obviously, and that's sand. It's hard to pack sand down too much. Put some of that mulch on the back, and what I'm not going to do is build a beautiful mound of mulch up to the trunk. We call that a mulch volcano. don't do that. Volcanoes are dangerous. Mulch volcanoes are dangerous. The tree knows where its trunk is. It doesn't want mulch touching the trunk because that holds moisture. And also is a great place for mice to live. And mice love tender bark. If you ever find, like after a heavy snow, branches that are held under the snow will often have all their bark taken off. So too much bark too much mulch at the bottom of a tree is very detrimental to the tree. Just want a skim of mulch. They say use a 3-3-3 rule. You can have mulch go as far out as 3 times the size of the canopy, and you can have mulch that's up to 3 inches thick, but you do not want mulch within 3 inches of the trunk if it's of any thickness. Mulch is often more for humans than it is for the tree because we like that aesthetic. But mulch can be really beneficial to new plantings because it holds some moisture in that won't dry out as much. And there we have it, fringe tree. This is a new one to me. I don't know of any other ones in Bourne.
I think Sally has one.
Oh, great.
Where's Sally? Yeah, I think she has.
Yeah, there's something of a new one in the horticulture world. So I look forward to seeing more of them around.
That's interesting. There's one at Heritage Plantation.
Oh, I'm sure there's one of everything there. That's a wonderful place.
That's a place.